Hello, this might surprise you to find out, but this is your internet friend, Robert Guderian. And today we have a big demo, and that is an object. And guess what? We're going to have some data. I'm going to have some methods to work with that data. And we're going to create our own set. We've seen the set object. It does set operations for us. And it's very easy to understand because we kind of get set operations. You can have the union, you can have the intersection, you can have the difference, and they're easy to describe. So we want one cohesive place to put all of our logic and data for a set object. So how do you think it's going to be implemented? Well, it holds many data pieces. So it's probably got some kind of list, data structure inside of it to hold that data. So I just turned on my iPad. And what is special about this data? There's no duplicates. And we definitely have an .add method, and we pass it a new piece of data. The constructor, there is one where you could pass it a list or some kind of iterable. I can say that one day. And it'll initialize your set with that data. I'm going to forget about that, and we're not going to worry about it. We're just going to have a empty set constructor that will set up all of our stuff, which is basically just going to be this list. And then we're going to have add, and then we'll add some methods to work with other sets, which is actually very cool. So this is some work from last time, and I'm going to save a new object called set, not a new code file called set. So we're going to reset our kernel just so we have everything from scratch here, and we'll get there. Okay, let's start this from scratch. We have a constraint of no duplicates. That's a big deal. So class set and def init set, and then we're going to say self dot set data is equal to an empty list. Do we need anything else? Not right now. Def add self new stuff. So we're going to add one piece of data to this list, but we don't want duplicates. Okay, if new stuff is not in my list, self.data, I know what my list is, then add it. Self.data.append new stuff. I'm going to add a string method. I guess I don't have a name. I was going to say, hello, my name is, because I really get a charge of that. Result. Return me data. It's British. Header is equal to me data. I just can call it out. And they're going to build up a string wherein I have everything. So for datum in data, me data, out is equal to out plus this datum, and a new line because I really like the way that looks. And then we're going to have out pot. Great. Out is equal to plus equal. No, I can't do it. I just can't do it. Out plus an ending brace. Good. Return out. Oh, I just wrote 16-line code and didn't test it. What a terrible idea. My set is equal to set, and it's uppercase set, so there's no namespace collision, right? There is a built-in method, which is probably a constructor, called set with a lowercase s. Python is case sensitive. If you have not noticed that yet, it's true. And we'll just print my set. And we'll see what happens. Probably nothing. It shouldn't blow. Oh! Self.data. I don't even have to look at the line number. I can just kind of like blur my eyes. Me data is nothing. My set dot add 1. And of course I can have mixed data types in here. There's no reason not to. And I should print that out again to see that it has indeed added some data. Cool. Cool. Here's a little cool thing. I could just have it keep track of strings, but I can also just cast whatever I have in here to a string, and it's going to call the string method on it. And now it has a 1. I'm going to add a new line here because I think that'd be pretty. That is pretty. Good. Let's try to add a second one to test that code. And it's still only one of them. Hey, this may be working. I think that we're good with that. So that means that our set works. We have a set of unique data. We've tried adding 2 pieces of data. I could try adding a third, but all the code paths have been tested. And by code path, I mean we've tested both sides of this if statement, running it and not. So how would we do difference and or intersection? We're going to start with difference maybe. So set difference, as a reminder, is if you have 2 sets, we don't have any of this. So it's going to be stuff in A, but not in B. So I have to have 2 sets. And generally, this returns a set. That's actually important too. So it feels very inbred. We're going to find out what this looks like. So I'm going to, we're going to jump over to the code. Perfect. Difference. Self and other. This and that, me and them. We are going to have a set method that is passed a set. And we're going to return a set that is stuff in A but not B. And I could rename these A and B. There's no reason not to. So I'm going to say for item in self dot data. That will take me through every piece of data inside of here. And if that data is not in other.data, can I do that? I have 2 sets, right? I have A, and there's some data, and B and some data. Yes, I do have access to this. So I can say 1, 2, and this is going to be 1, 4. A is 1 in B's data. Yes, it is. I'm not going to add that to C, which is my output. It's 4 in B data. No, it's not. So we're going to add it. And then this is my return value. And I do have access to all of B's data. Actually, because it's Python, everyone does. In Java, it's actually true too. This is how you would do equals comparisons in Java. So then I'm going to have a new set. I'm going to name it out is equal to a new set. And if it is not in there, out.add. Whoa. I was on a roll here. Item. Nope. Sorry. I don't know what I pressed. So legitimately, this is my return set. Starts off as empty. For every piece of data inside of me, I'm going to check the first one. Do you have this one? Yes. Don't add it to the other one. Do you have this one? No. Okay, add it to the other one. And we're going to return out. Then I'm going to create 2 sets. I was going to have 1 and 2. And then other set is going to be a new set. And other set is going to have 1 and 4. 1. Other set dot add 4. Then we're going to say print the difference on my set dot difference with other set. And this will return a set, which will get printed and will only have 2, which is the only value that is not in both of them. It's beautiful. It's beautiful, guys. Def, intersection. Pretty much the same deal. I'm just going to legitimately copy and paste it. So I'm going to say if it's in the other one, I keep it. And there we go. I have intersection now. That's it. These can't be the same method, unfortunately. It almost looks like copy and pasted code because I literally just copied and pasted it. But this this comparison being different makes it a very different method. And then we'll print the intersection between the two. Cool. Try set union. Actually, union's pretty easy. You should try that. This code is posted. cs.umanitoba.ca/tilde robg/1012/examples. It's there. And you can play with it. Or you can code it up by hand because it's nice. Like this is 45 lines of code, but not one is difficult. Which is what makes objects compelling. This is confusing, but it's in one place and it's easy to test. And now I can use it anywhere. Sorry, I get really excited about objects. You should see me in class. I just totally nerd out. Objects have one cohesive place to place data. That's a terrible sentence, but it's true. This is all about encapsulation. We have encapsulated all of the set stuff into an object, and we can reuse it and create many sets. We can create many objects that can interact. And they're simple. They're beautiful. I will talk to you later.